Hi, today's class we are going to discuss problems in electromagnetic induction. Previous class we have seen the theory of EMI, what is called magnetic flux, what is called magnetic induction, relation between the two, that is phi is equal to BA cos theta. For n terms it is NBA cos theta. Then Faraday's laws of EMI, in that the basic formula, induced EMF is rate of change of magnetic flux d by dt of n phi. If Lenz's law is also included, it should be minus. Then self-induction and mutual induction. Few formulas we have seen. Self-induction, phi is equal to Li. L is equal to phi by I. Another formula, E is equal to minus L into di by dt. From that, L can be calculated. In the case of mutual induction, the basic formula is phi is equal to Mi. Phi to magnetic flux linked with the secondary coil is equal to Mi1, current passing in the primary coil. 2-1, 1-2, like that we can write. Then second one, E is equal to minus M into di1 by dt. Here it is E2, EMF induced in the secondary coil. So we are putting E2. Okay, fine. Next, self-induction of a long solenoid carrying current. L is equal to mu naught N square A by L. For mutual induction, M is equal to mu naught N1 N2 A by L. Number of turns in primary, number of turns in secondary, area of the enclosed by the coil. Area A1 or A2. That also we have to, it is A2. Suppose primary and secondary coil has got same number of turns, means then these two formulas both are same. Mu naught N square A by L, directly we can write. Okay, fine. Next, methods of inducing EMF. Methods of inducing EMF. In methods of inducing EMF, we have seen three methods. First one, E is equal to minus d by dt of NBA cos theta is the basic formula. If magnetic induction alone changes, the formula is minus Na cos theta dB by dt. Area enclosed by the coil changes, means E is equal to minus BLV. Orientation of the coil, that means when the coil is rotated, the EMF induced is E is equal to NBA omega sin omega t. That is EM sin omega t. EM or VM, anything you can write. Maximum value of induced EMF. Okay, fine. So after this, transformer, we have seen, that is induced EMF in the secondary coil divided by induced EMF in the primary coil is equal to number of turns in secondary by number of turns in primary. That is nothing but turns ratio of the transformer. That is called turns ratio. So ES by EP is equal to NS by NP, that is equal to K. For ideal transformer, power output is equal to power input. That is no power loss. Generally, there is a power loss. Ideal transformer means it is assumed that output power is equal to input power. Output power means ESIS. Input power means EPIP. Voltage into current, we call it as power. So ES by EP is nothing but IP by IS. But already we know ES by EP is nothing but NS by NP. Okay, so this is equation connecting or used for ideal transformer. Then efficiency of a transformer. Eta is equal to power output by power input into 100%. Output power by input power into 100%. Output power by input power into 100% means for ideal transformer efficiency is 100%. For all other cases, always transformer efficiency is less than 1 or less than 100%. Okay. So these are the theory or information we have seen in electromagnetic induction. Now, based on this, we'll work out the problems. First problem, the flux linked with the coil at any instant t is given by phi b is equal to 10t square minus 50t plus 250. Calculate the induced EMF at t is equal to 5 seconds. This is a question. EMF E is equal to rate of change of magnetic flux. E is equal to d phi by dt. Rate of change of magnetic flux. So you differentiate this. Question is minus, of course. Generally, EMF only calculated, but the Faraday's lenses like it is minus sign. So minus 20t, differentiate 20t minus 50. Outside minus. So it is minus 20t plus 50 is EMF. At t is equal to 3 seconds, EMF will be minus 20 into t is 3 plus 50. So minus 60 plus 50. That should be minus 10 volt. So EMF is minus 10 volt. Okay, fine. Second problem. When the current changes from plus 2 ampere to minus 2 ampere in 0.05 second, an EMF of 8 volt is induced in the coil. Calculate the coefficient of self-induction. We know the formula for self-induction. Just now we have seen E is equal to minus L into di by dt. So L is equal to minus E by di by dt. What is EMF given here? 8 volts. And current changes from plus 2 ampere to minus 2 ampere. So minus E into dt will go to numerator by di minus 8 volts. Time given is 0.05 second. Current plus 2 to minus 2. Final minus initial. Final is minus 2 minus initial is 2. So minus 4. Minus minus cancelled. 8 by 4 is 2. So L is equal to 2 into 0.05. 2 into 5 is 10. So it should be 0.1 Henry. Correct? So this is second problem. Induced EMF in the self-induction or in a coil. Next, third one. A circular coil of cross-sectional area 4 centimeters square has 10 turns. It is placed at the center of a long solenoid that has 15 turns per centimeter. Cross-sectional area 10 centimeters square. The axis of the coil coincides with axis of solenoid. What is the mutual inductance? Mutual inductance of a long solenoid carrying current is M is equal to mu naught N1 N2 A by L. Already we have discussed it is area of the second coil. So value 4 pi into 10 power minus 7. Number of turns 10, N1 and N2 will be 15 turns per centimeter. That you have to convert into meter. So 10 power minus 2 denominator, 15 into 10 power minus 2 denominator, it will become 10 power plus 2 in numerator into pi r square. So cross-sectional area is 4 centimeters square. 4 into 10 power minus 4. Length here not given. Not given means 1. Calculation we can do, but basic information how to calculate this. That's what our information. Okay. So find out that value will be 7.54 into 10 power minus 6 Henry. 10 power minus 6 is micro Henry. 7.54 micro Henry is the answer. Fourth problem. In a transformer, the number of turns in primary and number of turns in secondary are 410 and 1230 respectively. If the current in primary is 6 ampere, what is the current in the secondary coil? Transformer, number of turns in primary and number of turns in secondary. Transformer formula psi S by psi P or ES by EP or E2 by E1. Secondary EMF by primary EMF. Anything you can put. Is equal to NS by NP is equal to IP by IS. Question, you have to calculate the number of turns in the secondary coil. NS you have to calculate. So NS is equal to NP into IP by IS. What is NP? Primary number of turns. 410. Into IP by IS. You have to calculate secondary current. You have to calculate IS. IS is NS. IS is equal to NPIP by NS. So NP primary number of turn is 410. Primary current 6 ampere. Secondary number of turn is 1000 to 230. Cancel 2 times. So IS is equal to 6 by 2, 3 ampere. 3 ampere. Five. A step-down transformer reduces the supply voltage from 220 volts to 11 volts and increase the current from 6 ampere to 100 ampere. Calculate its efficiency. Efficiency of a transformer, power output by power input into 100%. Power output is ESIS. Power input is EPIP into 100%. What you have to calculate? Efficiency only you have to calculate. ESIS by EPIP into 100%. So the value eta ES 11 volts, IS 100 ampere, EP 220 volts, IP 6 ampere. 1 0 cancels, 11 and 22 means 2 times 10 by 12. 10 by 12 means 5 by 6. 5 by 6 is 0.83 into 100%. That is 83%. Efficiency is 83%. So everywhere you have to multiply by 100. Correct? So this is efficiency of a transformer. Okay. 6. The magnetic flux passes perpendicular to the plane of the circuit and is directed into the paper. If phi is equal to 2tq plus 3t square plus 8t plus 5 into 10 power minus 3 Weber. What is the induced EMF? This is the question. Induced EMF psi or E is equal to minus N into d phi by dt. What is number of turns given? Not given. Not given means 1. That's all. d phi. Differentiate this. 6t square plus 6t plus 8 into 10 power minus 3. So E will be given t is equal to 3 seconds. T is equal to 3 seconds given in the problem. So I can write minus 6 into 3 square 9. 6 into 3 plus 8 into 10 power minus 3. 54 plus 18 plus 8 into 10 power minus 3. 54 plus 18, 72 plus 8. So E will be minus. Question is magnitude of induced EMF. Minus, of course. No, sir, magnitude alone I want means you can write 80 millivolt. Actually, it is minus 80 millivolts. Magnitude alone means you can write 80 millivolts. Correct? So this is induced EMF in the coil. 7th problem. A solenoid of 500 turns is wound on iron core of relative permeability 800. The length and radius are 40 centimeter and 3 centimeter respectively. Calculate the average EMF induced in the solenoid if the current changes from 0 to 3 ampere in 0.4 second. Number of turns 500, relative permeability 800, length and radius 40 and 3. Calculate induced EMF change in current 0 to 3 ampere in 0.4 seconds. So di by dt, that value. Okay, first induced EMF formula minus L into di by dt. For that, L to be calculated. L is not given in the problem. So L is equal to mu naught mu r n square A by L. 4 pi into 10 power minus 7. Relative permeability given as 800. Number of turns 500 turns 500 square into area is pi r square. Pi radius is 3 centimeter. 3 into 10 power minus 2 the whole square. Whole divided by L. Length is 40 centimeter. 0.4 meter. So substitute all the values, you are getting 1.775 Henry. Once L calculated means E easily can calculate. What is the value? E is equal to minus L minus 1.775 into di by dt. What is change in current? 0 to 3 ampere. So 3 minus 0, final minus initial. Time is 0.4. Minus 1.775. 3 by 0.4. 30 by 4 is 7.5. Calculate minus 13.125 volt. Here two things you have to calculate. Generally L value will be given. Here L value first you calculate, then use that to calculate the induced EMF for a coil. Okay. Eighth problem. The self-inductance of air core solenoid is 4.8 millihenry. If its core is replaced by iron core, then its self-induction is 1.8 Henry. Find the relative permeability of iron. Simple. First we'll write the formula. Air core mu naught n square A by L. Iron core mu naught mu r n square A by L. L air by L iron. If you divide mu naught n square A by L, mu naught n square A by L cancels. 1 by mu r you will get. What is L air and L iron? 4.8 into 10 power minus 3 divided by L iron is 1.8. So we can write mu r is equal to 1.8 into 10 power 3 by 4.8. 1800 by 4.8. That is 3000 by 8. Simplify, no problem. It is a number. Relative permeability is a number. There is no unit. Okay, ma? Fine. Ninth problem. The current flowing in the first coil changes from 2 ampere to 10 ampere in 0.4 seconds. Find the mutual inductance between the two coils if an EMF of 60 millivolt is induced in the second coil. Also calculate induced EMF when the current changes from 4 ampere to 16 ampere in 0.03 seconds. Actually, it is single formula only. Two different data they have given. Induced EMF is E2 or Psi2 is equal to minus, question is magnitude only, M into dI1 by dt. M means second coil with respect to first coil mutual inductance value. What is M? That only you have to calculate. Therefore, M is equal to E by di by dt. What is EMF here? 60 millivolts. Current changes 2 ampere to 10 ampere. So 10 minus 2 divided by time is 0.4 second. So 66 into 0.4 into 10 power minus 2 by 8. Simplify, it is 4 into 10 power minus 3. That is 24 by 8. M21 is 3 into 10 power minus 3 Henry. That is 3 millihenry. Same formula, another set of data is given. E2 is equal to M21. E2 by M21 dash, E2 dash by dI1 by dt. Same coil. Coil is same is value of M from the previous you are using. You have to calculate induced EMF. Same question. Calculate E2 dash. So E2 dash is equal to M21 into di dash by d1 or dt. What is M21? We have calculated 3 millihenry. Di by dt changes 4 ampere to 16 ampere. That means 16 minus 4. What is the time given? In 0.03 second. So E2 dash is equal to 3 into 12 into 10 power minus 3 by 3 into 10 power minus 2. 12 into 10 power minus 1. 1.2 volt. 1.2 volt is the EMF induced. So first we have to calculate mutual inductance. Use that value to calculate induced EMF. Okay, fine. 10th problem. An ideal transformer has 460 and 40,000 turns. 460 NP, 40,000 NS turns. Find the voltage developed per turn of the secondary if the transformer is connected with 230 volts main. That is EP is 230 volt. Secondary is given to a load of resistance 10 power 4. RS is 10 power 4 ohms. Calculate the power delivered. EP, NP, NS. First you calculate ES. Therefore, ES by EP is equal to NS by NP. What is the value? 230. ES we have to calculate. ES by NS is equal to EP by NP. ES by NS is equal to EP by NP. EP is nothing but 230. NP is nothing but 460. That is half. So ES is equal to NS by 2. Anything you can do. You can very well write ES is equal to NS into EP by NP also. Same concept only. NS by 2. That is 40,000 by 2. 20,000 turns. 20,000 volt. This is 0.5 volt per turn. 1 by 2 is 0.5 volt. Per turn you have to calculate, that is the question. So we are writing 0.5 volt per turn. 40,000 turns means 20,000 will be the volt. Okay. Every turn it is 0.5 volt. 40,000 turns is the question. 40,000 into 0.5 will be 20,000 volt. Okay. What is the power? Therefore, power delivered. Power delivered means normally power will be delivered only in the secondary side. So, power is equal to ES/IS. 20,000 into current is ES by RS. 20,000 into 20,000 by 10,000 RS. This is 2 times. So you will get 40,000, that is 40 kilowatts. Power delivered to the load is 40 kilowatts. Excellent problem, this is. Okay, next. 11th problem. A square coil of side 30 centimeter with 500 turns is kept in a uniform magnetic field of 0.4 Tesla. The plane of the coil is inclined at an angle of 30 degrees to the field. Calculate the magnetic flux. 500 turns, magnetic field 0.4 Tesla, square coil. Angle subtended is 30 degrees with the field. Total flux is equal to formula NBA cos theta. Generally it is BA cos theta. So N5 we are calculating here. N5 only, don't cancel N and N. Total flux means you have to multiply by N. Further only we have written. So number of terms here 500. B value 0.4 into A square coil of side 30 centimeter. Square means side into side. So 30 into 30, 10 power minus 4. See the question. The plane of the coil is inclined at an angle of 60 degree. Plane with the magnetic field only we have to calculate. Plane with the magnetic field means 90 minus 60. Plane of the coil itself is inclined with the magnetic field. So total angle should be 90 minus 30. That should be 60 degree cos 60. So total flux N5 is equal to 5 into 0.4, 2, 3 into 3, 9. These 2 zeros and these 2 zeros, 10 power minus 4 cancel. Cos 60 is 1 by 2. So answer is 9 Weber. 9 Weber is the answer. Okay. Twelfth one. A straight metal wire crosses a magnetic field of flux 4 milliweber in a time 0.4 second. Find the magnitude of EMF induced. It's a straight problem. EMF induced psi or E is equal to d phi by dt. What is magnetic flux change? 4 milliweber. 4 into 10 power minus 3. Time taken 0.4. So this is 10 into 10 power minus 3. That is 10 power minus 2 volt or 0.01 volt. 10 millivolts. Anything you can write, no problem. All are same. Thirteenth problem. A closely wound circular coil of radius 0.02 meter is placed perpendicular to the magnetic field. When the magnetic field is changed from 8,000 Tesla to 2,000 Tesla in 6 seconds, an EMF of 44 volts is induced. Calculate the number of turns in the coil. EMF induced. First we'll calculate that. E is equal to minus N into d phi by dt. Magnitude alone we are taking. See the question. E is placed perpendicular to the magnetic field. When the magnetic field is changed from 8,000 to 2,000 in 0.1 in 6 seconds, some EMF is induced. Is placed perpendicular. Plane of the coil is already perpendicular with the magnetic field. The plane itself is placed perpendicular. So, normal is parallel now. Normal and magnetic field. Plane is perpendicular means this is normal. This is magnetic field. Magnetic field is passing perpendicular to the plane, but theta is the angle between normal and magnetic field. So in this case, theta is equal to 0. So E is equal to N into d by dt of BA cos theta. Our aim is to calculate N. So N is equal to formula. We can finish this. E is equal to N A cos theta into dB by dt. Here theta is equal to 0. So what will happen? N is equal to E by A dB by dt. A is pi r square. Therefore, N is equal to E value 44 volts. EMF induced is 44 volts. 44 by A is pi r square. Radius is 0.02 the whole square into dB by dt. That is 8,000 minus 2,000 by time taken. What is the value? 6 seconds. So N is equal to 44 by pi into 2 square is 4 into 10 power minus 4. 8,000 minus 2,000 is 6,000 by 6. So 1,000. 1000 and 10 power minus 4 means 10 power minus 1. Numerator plus 1. 4 and 44 is 11 into 10 by 3.14. So n will be 110 by 3.14, nearly 35 turns. 35 turns. Very good problem. It is 35 turns. Okay, question number 14. A rectangular coil of area 6 centimeter square having 3500 turns is kept in a uniform magnetic field of 0.4 Tesla. Initially, the plane of the coil is perpendicular to the field and then rotated through 180 degree. If R is equal to 35 ohms, find the amount of charge flowing through the coil. Theta final. Initially, it is plane of the coil is perpendicular to the field. Then rotated through 180 degree. So final minus initial 90 degree. Let it be. Formula for induced EMF psi or E is equal to minus d by dt of n phi. Initial flux phi I. NBA cos 0. Already we have discussed. Plane of the coil is perpendicular to the field. Plane of the coil perpendicular means normal only we need. Normal is parallel to magnetic field. So here theta is equal to 0, NBA. Final flux. Rotated through 180 degree. NBA cos 180. Cos 180 is minus 1. So minus NBA. Formula E is equal to minus d by dt of or n into d phi by dt. So change in flux. What is number of turns here given? Change in flux first we will calculate. Final minus initial. Final is NBA minus initial is NBA minus 2 NBA. Here one minus, so it will become plus. 2 NBA is E. 2 into number of turns given 3500 turns into magnetic induction value 0.4 Tesla. A is pi r square into pi radius. Area itself is given. That is 6 centimeter square. 6 into 10 power minus 4. Centimeter is 10 power minus 2 centimeter square. So 10 power minus 4. Simplify, you are getting 168 into 10 power minus 2 volt. Question is, what is the current? I is equal to E by R. 168 into 10 power minus 2 by resistance is 35 ohms. Calculate 4.8 into 10 power minus 2. Question, not the current to be calculated. You have to calculate the charge. charge is current into time. I is equal to Q by T. Q is equal to I into T. I is 4.8 into 10 power minus 2. Time taken not given 1. So 4.8 10 power minus 2 coulomb. The big one, but the concept is simple. First, you have to calculate the change in flux, then induced EMF. Once EMF calculated means calculate the current. Current calculated means calculate the charge. So change in flux, EMF, current, charge. 4 parts we have to calculate. Okay. 15th one, a coil of 200 turns carries a current of 4 ampere. If the magnetic flux through the coil is 6 into 10 power minus 5 Weber, find the magnetic energy stored in the medium. Actually, this formula we have not seen. Electric energy, first chapter, stored in a capacitor, half CV square or Q square by 2C, that we have studied. Like that, magnetic energy stored in the coil, UB, that is UE, this is UB, half LI square is the formula. L is the self-induction, I is the current passing through. But N phi is equal to Li. L is equal to N phi by I. Self-induction of a coil formula, N phi is equal to Li. Therefore, UB is equal to half N phi by I into I square. 1 I cancels. UB is equal to half. Number of turns given 200 into magnetic flux 6 into 10 power minus 5 Weber into the current. The current value is 4 ampere. 2 times 2 into 2, 4, 4 into 6, 24. 10 power 2, 10 power minus 5, 10 power minus 3, 24 millijoules or 0.024 joule. Anything you can write. Okay. So generally, magnetic energy, electric energy in electrostatics. Magnetic current means this is magnetic energy, there electrostatics, electric energy. Transformer question, we have seen many problems. For long range power transmission, what is the advantage? That also we have studied in theory. Long range power transmission means generally from the transmitting end to receiving end, when power is transmitted, there will be a loss of power. So output power will be always less than input power. That means efficiency is less than 1. If you are not using a transformer for transmitting the power, then the power loss will be huge one, around 80 to 85% power loss. Then what is the purpose of sending that power? So we have to use a step-up transformer in the transmitting end. That will be transmitted to the receiving end. Loss of power will be so small if transformer is used. Next question you will ask, sir, for domestic supply we need only 220 volts. For operating machines in the machinery in the industries, we need 1100 volts. To operate a machine in cinema theater, we need 440 volts. If you are using a step-up transformer, we will receive very high voltage in the receiving end. Then how to eliminate? Simple. Use a step-down transformer in the receiving end. Whatever voltage you have stepped up, exactly step down, don't do it. then domestic supply 220 volts only you can use. But 220 volts for domestic supply, 440 volts for one purpose, 1100 volts for another purpose means different step down transformer we can use at the receiving end. This is mainly because the power loss is very minimized. Okay. So these are the problems and formulae related to electromagnetic induction chapter. Okay. Thank you. We'll continue.